All right. So let's imagine I have a spinner. So you don't need to take notes yet. I'll tell you when to start taking notes. This is more for your revision. I don't know if you've been to a year level assembly where someone gets something on Google and they spin the wheel to like select a winner or something. So let's imagine I have a spinner that looks something like this, numbered 1, 2, and 3. And maybe I'll color the regions differently. So one part I'll color in purple, one part I'll color in yellow. Pretty colors, I know. And one part I'll color in green. So does it matter? Let's say if I spin the wheel and you get the color right, I give you $50. I'm not going to do this because I'll end up very, very poor. Does it matter which color you pick?
No. You got the same chance.
Same chance. What do you mean by that, Josh?
Like, there's 3 colors, and that means you have 33% chance of getting it right.
I think the purple's bigger than yellow.
Yeah. So yeah. Okay.
That spinner's not saying.
Okay. So you guys listening? So this is Louis. This is where I'm going with this. All right. So the idea with the one on the left, Talia. The idea with the one on the left is that they're supposed to be equal regions, so the same space. What's different about the one on the right?
Not equal.
What's not equal?
Purple side, number 1 carries more majority of the spinner.
Okay, so if I give you $50 if it lands on purple, which one do you want to pick?
Green.
The left one or the right one?
Right. Left.
Why?
Because it's half
You got percentage. You got more of a chance of landing on purple than still on the one on the left.
Excellent. So year nines, you might have seen something like this.
Yeah. What?
I've never had to go for a teacher.
Okay, so before I ask for some numbers,
Do you remember like us doing this in a sports class?
we often write PR, bracket, something inside the bracket, and then close the bracket. What does the PR mean? Probability. So that's what this topic's all about. So for every event, I'm going to assign a probability. That is a number which measures how likely it is the event's going to occur. So a lot of you told me the probability here. What's the probability of the spinner landing on purple on the left? 1 on 3. Why is it 1 on 3? Why isn't the probability a half or 1/10?
Because it's 3.
3 equally likely outcomes. So if I have, for example, 10 equally likely outcomes, the probability of getting one of them is 1/10. 5 equally likely outcomes, 1/5. 3 equally likely outcomes, 1/3. Okay. All right. What about the one on the right? What's the probability here?
Half.
Why is it a half, Stuart?
Because or half the circle, half the spinner.
Very good. So, are the outcomes equally likely here?
No.
Okay, you can see that, right? Like purple is bigger. I lose lots of money if you play this game. So please note it's not 1 on 3, even though there are 3 equally likely outcomes. They're not equally likely. That's the point. Equally likely, 1 on 3. Not equally likely, it's not 1 on 3. Okay.
Wouldn't saying which spinner is better, if you look at that from our point of view, wouldn't we choose the right one?
Yes. Okay, because you have a higher probability of winning. Half is larger than a third. We cannot play that game because I don't have enough $50 notes.
I'll take 100.
You can just give us a little bit more.
No.
No,
You see, here's the thing.
How about we all just play it once?
Because I understand maths, I would not play this game with you. At least I wouldn't be the one paying the money. You see?
I'd be happy with a $20.
What if it's $50?
That's not how that works.
You pay $1,000 to say that.
I would pay
All right, folks. Now you need to start taking some notes. All right. So all books should be out. You should have a heading, 2-step chance experiments, and you should copy down everything that I'm writing. Okay. So here's the example. I am going to spin the spinner. All outcomes are equally likely there. Just put the numbers 1, 2, and 3. Okay, so let me introduce some terminology. In probability, we often talk about an experiment or an event. So I'll call this the experiment. A lot of you are in Miss Stewart's science class, I believe. Actually, I'll be there this afternoon because she's away today. We talk about the experiment and we talk about the outcome. So let's go back to the previous example for a moment. What do you think the experiment is here? Let's assume we're spinning this one. So in probability, there's always an experiment and there's always an outcome. So what's the experiment? Let's say I spin this wheel. What would the experiment be? Stuart?
Like how likely it is what number it's going to land on.
Even simpler than that. It's just spinning the wheel.
Oh.
Okay? Shannon?
How many times is Mr. Chu's going to give us $50? That's a bit, that's further down. So that's more like the sample space. Okay? All right. Let's hold that thought. Because I think I've confused you. Okay, so just stay with me, guys. In this first example, I only did one thing. I spun the wheel, right? Everything that we're going to do in this topic is going to involve more than one thing. So in this example, I'm setting up the 3-colored spinner, but I'm also going to flip a coin. So
with the coin, what are the two possible outcomes you could get? Heads and tails. So I'm going to abbreviate that with the letters H and T. Sorry, Sam?
Did we do this last year?
Yes.
We did. We did do this last year.
This last year you said it.
All right. So the first question I want you to consider is the following. What are the possible outcomes of this experiment? The way we're going to do this is we're going to draw a diagram. It's called a tree diagram. All right. So you can all do this. Probability is actually quite a challenging topic, but everyone in this room can do this part. Okay. So this is what I want you to draw. So do you want to do the wheel first or the coin first? Okay. I can only pick one. So it actually doesn't matter which one you pick first. So you can do both.
Oh no, I hate these.
I will try to teach it better this year, Talia. So if you weren't in my class last year, I accidentally tried to teach year 10 material to the year 8 class last year. I'll try not to do that this year. My bad. Yes, you should write this. So can I just check? Let's go with Miss Steiner's class last year. Did you draw these diagrams? You did? And Mrs. Evans' class? Probably. Can you be
No, we didn't.
no tree diagram?
We didn't really do much.
Well, make sure you get this down then.
Well, we know how to do it, we just didn't do it properly last
We didn't do much of it.
Yeah.
Oh!
True. I agree.
So year 9s, I've drawn both tree diagrams, but the message I want to convey to you is you only need to draw one of them. You don't need to draw both. I just want to demonstrate that either is fine. Okay, so let's start by looking a bit more closely at some of these events. So how many possible outcomes are there in total?
6.
Did you catch that, Talia?
Yeah.
How many possible outcomes are there? Okay, why are there 6? Very good. 2 times 3 gives you 6. Okay, so what if I asked you this question now? So I'll draw the tree diagram again. What is the probability of getting a heads followed by a 1?
1 over 6.
Okay, so you've told me there are 6 possible outcomes in total. And you said that there are 1 in 6. Now, remember the situation we had earlier. There are 3 possible outcomes here, but the probability wasn't a third because the outcomes weren't equally likely. So one of the things that I need to be convinced of is, you've said that there are 6 outcomes. You've told me the probability is 1 on 6. So that suggests to me that each outcome in this tree diagram is equally likely. How do we know that though? Okay, so the spinner had equal pieces? Yes. What about the coin? Half and half. Okay. Are you talking to me?
Oh, no, not me. I
Okay.
was talking to Shannon.
Okay, all right. So there's actually something missing on this tree diagram.
Is it the spinner?
Not the spinner. So if you were in my class last year, I never drew a tree diagram like this. I always put some numbers on the tree. Stuart?
On the branches, you did the probability of each event.
Nice. Okay.
So
So
you have to draw one.
so what I would like you to do now, year nines, is I would like you to draw a new tree diagram, but this time I want you to put the probabilities on. So we've got heads, we've got tails, so allow a bit more space this time. So if I toss a fair coin, how many possibilities are there? Toss a coin. 2 possibilities. And what's the probability of getting heads? All right. Now I've got the 3-colored spinner. What's the probability of landing on the number 1?
1 and 3.
1 and 3, because there are 3 equally likely outcomes. So if I know what coin I have, the probability of getting each number on the spinner is 1/3. When you draw your tree diagrams, if it's not too large, please put the probabilities on the tree diagram. Okay, last step. So if I know, Talia, if I know that these probabilities are half, and I know that these probabilities are 1/3, the next question I want to ask is, what is the probability of getting an individual outcome such as H1, H2, H3, T1, T2, T3? So unless you know this, it's not clear how to get the probabilities of each individual outcome at the end. But if you've got a good memory, you might remember how to do this. So Josh, you want to
I don't know, but can you just do like 1/2 times 1/3?
That is exactly what you do. So I think you should write this sentence down, and I'll write it here. So write down the green stuff. To get the probability, all right, so year nines. I know I've covered a lot already. I'm going to go over this again and again over the next couple of weeks. So don't panic if you don't get it all today. That's fine. That's normal in a maths class. Okay. Today, the big idea is the tree diagram to map everything out. We'll spend more time on the probabilities next week. But do get this sentence down. So if I want to find out the probability of getting H and 1, what I need to do is take the numbers a half and the numbers 1/3 and multiply them together. This is why I gave out a booklet covering fractions because I have a suspicion that you may not have done this in a long time, adding and multiplying fractions. So I won't go over it today. The way you multiply two fractions is to multiply the numerators together, that's the numbers on top, and to multiply the denominators together, that's the numbers on the bottom. So literally, 1 times 1 on top, 2 times 3 on the bottom. It's actually easier than adding fractions. Multiplying is easier.
What bonobo? What, like you? Alright, I think this two wants us to be quiet now. I can see it.
Post this on the YouTube channel.
Wait, shut up. Please. Thank you.
Okay. So, before, you told me that the probability of getting a heads and a 1 was 1 in 6. And you were correct. The outcomes are equally likely because it's half and half. 1/3, 1/3, 1/3, 1/3, 1/3, 1/3. When you do this calculation, you'll get the same result every time. You'll get 1 in 6. Later, later we will have times where the probabilities aren't the same. So you'll need to pay attention to that. Okay? But for now, they're going to be the same. So when you do exercise 9A, which I'll just do one example to get you started. We might run out of time. All the probabilities will be the same on the tree diagram. Later, they won't be the same. So I think what I'll do is I will finish with, let's do question 4. Let me just check the time. All right, so we'll have a bit of time to get started. So in this, this is a bit ambiguous. Okay, so in this question, you draw 2 cards.
Oh, we do?
Yeah. Do you understand sarcasm yet at your age?
Yeah.
Okay.
Are you being sarcastic?
Not today.
Yeah, was that sarcasm?
No.
Shut up.
How many cards are in the deck? Is it 54?
It's 52.
How the hell did you guys even know that? I would have said like 50.
This is pick up 52.
So I guess it's 54 if you put in 2 jokers.
And if it's a standard deck, then it would be
It's just 4 times 12.
52. Because there's 13 cards and 4 suits.
So wouldn't a standard deck include the jokers?
4 times 12.
No. Because usually you don't play. Normally, when people say standard deck, they don't play with the jokers. Yeah.
What's that say?
So it's 50.
Did I say court after?
With the first contract.
That's what I said to it. It's not
Okay. Just a word of warning. This is quite a large tree diagram. So what's happening here, guys, is I'm drawing 2 cards out of a deck,
And I'm just interested in what the suits of the card is. So there's 4 suits in the deck of cards. Hearts, diamonds, clubs, and spades. And I want to do it again after the first time. So how many branches do I need for the second step?
What's that last word?
Spade.
Huh?
Spade. 4.
What?
Spade.
SPADE.
No.
Suits. Sorry. Yeah. Now, because I'm lazy, I'm just going to write H, D, C, and S. Okay. As you can tell, it can quickly become overwhelming using a tree diagram. Okay, so just take a moment to get the tree diagram down.
Yeah, I'm gonna.
Now, remember what I said about putting numbers on the tree diagram. If you're paying close attention, you should see something. So I'll draw your attention to this. I'm replacing the first card. Because I replaced the first card, this makes the question much, much easier. If I didn't put it back, it would make it harder.
Oh yeah, because then there's only 51 cards left.
Okay, so the probabilities are actually going to be the same. All right, so let's just look at the first step here. How many suits are there? So what's the probability of selecting one of those suits? 1/4. Okay, don't write the numbers yet, because I'm going to be lazy and do something else.
All right. I put the first card back before selecting the second card. What's the probability of getting one of the suits? It hasn't changed because I've still got all 52 cards in.
Okay, so I'm going to be really lazy and I'm going to say all probabilities on the tree diagram are 1/4. Okay, so if you did it on the test, I'm fine with that. Okay, because there's no insight needed to write the number 1/4 20 times. Okay, you've got better things to do with your life than that.
You have to write the thing you just wrote.
The orange thing?
Yeah.
Yes, you should write that.
Put it B instead of P.
Okay. How many outcomes are there in total? 4 times 4 gives you 16. You can also count down the right, 16. Okay, so let's answer some questions now. The first question that we are asked is, what is the probability of getting at least 1 diamond?
1 in 8.
No, and 6 to multiply with 6. Yeah.
Okay, so what we need to do here is we need to check every outcome and see whether there's a diamond in place. Okay, so let's start with the first one. Heart. Is there a diamond there?
Yeah. No.
No diamonds.
It's still 1/4.
No, it's not 1/4. We will see that in a moment. Okay. HD. Let's just work through this systematically, and then we'll look at the answer. HD. Does that have a diamond?
Yes.
Yes.
Okay, so I'm going to put a little asterisk there to tell myself that I'm counting that one. Okay. HC. Does that have a diamond?
No.
HS?
No.
No? Okay. Diamond on the first one.
Yeah.
Do I need to check these 4 now?
No.
No, because I've already got one. Right, all of these 4 outcomes already have the diamond here. Okay,
So I've already got 5.
So it's 7.
Yes, because you've got one diamond here and one diamond here, and these two aren't diamonds. Okay. 7 outcomes out of 16 equally likely outcomes. So yes, it is 7 over 16. So this is question 4 of the first exercise in this topic. You see why people might say probability is a bit challenging? There's a lot of work involved in just one question. Okay? Now, I think you can all draw the tree diagram. And that's the first step. Okay? So today, all I want you to worry about is the tree diagram. If you can draw this, that's what I want from today. We've got 3 or 4 weeks to get this right. Okay? All right. I'll do a couple more, and I don't know if we'll run out of time. So the time is, so we've got about 15 minutes. All right. In this next part, Talia, Harry. In this next part, we are asked, what is the probability of getting a club and a heart? And it doesn't matter what the order is, because they haven't told us that. 2 and 16. Okay. Yes, I agree. Can you tell me where to find those possibilities on the tree diagram? So,
There's a club with it, and on the club, there's a heart with it.
So go to the heart first and get the club,
Get the club,
or go to the club
and get the heart.
and get the heart.
Yes.
Well, simplified, wouldn't it be just 1 over 8? So
Yes. See why we needed fractions here?
216
Yep. All right, we'll do 2 more, and then we'll call it a day here. Okay, this one's easy. At least I think this one's easier. What is the pro? No, 2 spades.
Yeah.
Oh wait, no, sorry. Yeah, that was...
Okay, so I'm drawing 2 cards from the deck, and I'm putting the first card back. So there's only one way to get the same suit both times. SF. Okay. I'm gonna run out of colors soon.
116.
Yeah, 1 over 16 is correct. Okay. All right, last one. And maybe we can negotiate something fun to do to finish the class. All right. Not a heart. It's phrased a little bit strangely.
Maybe the opposite of at least 1 diamond. Like
4, 5, 6,
9 out of
7, 8, 9.
no, yeah, 9.
9, 16.
Okay, let's go with one person speaking.
9, 16.
Okay, so you've given me a number, Matt.
Okay,
But where did the number come
so
from?
you skip the heart completely. The top one. You
Okay.
skip the heart section completely. And then on the diamond, on every other one, you just skip the H and count all the others.
Right. So Matt is saying we're not going to count this section at all because that's already got a heart here. Yeah? Okay. I like that. Okay, and then you're saying skip the first heart in every other one. So that leaves you with 3 plus 3 plus 3. Okay? I like it.
Is that correct?
Yes.
All right, year nines, you've guys listening. You've done well to listen to me for almost a full period. So I want to open up an opportunity for questions now. One of the things that can happen in a maths class is the teacher keeps talking, and then you find out, hey, I didn't understand what Mr. Chi was talking about for the last 20 minutes. So if I've said something or done something today that didn't make sense, now's a good time to ask a question. And there's no shame in asking a question, because if you've got the question, chances are 4 or 5 other people in the room also have the same question as you. Now,
Mr. Chu, did you want this?
the booklet? No, the booklet is yours to keep. So, every time I ask, no one asks, but I'll still ask. Do you want to ask me a question?
Nah, I'm all good.
Okay, so you're going to ace this topic.
No.
Well then,
Holidays or something.
okay, well, let me end the recording and then we can talk about that. Yeah. All right.